Hi, in this session, we are going to look into converting an ER diagram to a relational model. And this video assumes that you're familiar with ER diagrams and relational models, although the key concepts will be briefly discussed here. Before we begin, let's look into what an ER diagram is and how does it compare to a relational model very quickly. An ER diagram is usually composed of three main building blocks. The first one being an entity, which is an object from the real world. And the properties are the features of an entity, which are referred to as attributes. And the relationship, which is how an entity is connected to one or more entities in the diagram. The name ER diagram comes from the entity relationship keywords. And on the other hand, a relational model is about implementing the ER diagram in the real world, its formulas to physical schema of a database. There are three main building blocks again. They're known as a relation, attribute, and keys. A relation is what holds the data. It is a table, and it is saved in a tabular format. Attributes have the same concept as in an ER diagram. They refer to the properties of the entity or the object in consideration. The key is a unique attribute or set of attributes that can be used to identify the tuples, which are the rows in a relation. And if it can uniquely identify them, then it is constructed as the key of a relational model. The goal behind the mapping of an ER diagram to a relational model is to preserve all the information, which includes all the attributes. And let's start by focusing on the ER diagram, what we want to identify, which is the regular entities, which refers to the strong entities. And you choose the simple attributes, whatever exists for those entities. Then you want to identify the primary key and any simple attributes of the entity. Next up is including the foreign key, the relationship, and any attributes of the relationship itself. A quick note, you can have attributes coming from an entity as well as attributes that are associated with a relationship. So keep that in mind when you start constructing the relational model conversion. Now, here are some key concepts which revolve around what an entity is, what are attributes, what are composite attributes, and what are the key attributes, along with some real-world examples. So an entity represents an object in the mini world, which is of interest, and it can be any physical object, for example, a person, an automobile, a house, or it can be a less tangible concept, example, a company, a job, an academic course, or a business transaction. Now, an attribute is used for describing an entity in detail by using the properties that can be considered as characterization of entities. Each attribute has a value that comes from a domain or a set of meaningful values. For example, a person might be described by their name, the date of birth, and their gender. And these are all individual attributes which will have a particular value for each individual or each person. Now, a composite attribute is one that is composed of smaller parts, and an atomic attribute is one that cannot be decomposed any further or cannot be divided any further. To give you an example, a date of birth attribute can be considered as a composite attribute because it is composed of the month, day, and year. Now, the next concept here is the key attributes of an entity, which refers to the minimal collection of attributes. Most of the times it considers a single attribute, but it can have more than one. A minimal collection of attributes that can uniquely identify any two entities or more of the same type. Now, an entity can have more than one key. For example, if you're talking about a car entity, it can have a registration number and state, which can uniquely identify each car, or you can do the same with the vehicle ID. Hence, we can use both of these as the keys. Next, let's talk about single versus multi-valued attributes. Now, if you consider the person entity for this slide, the idea is that a person has a single SSN, one date of birth, and one composite name, hence single valued attributes. Now, a person can have 1, 0, or more academic degrees. Same thing for dependents or for spouses, hence the term multi-valued attributes. Next, we'll talk about stored and derived attributes. Derived attributes are those that can be calculated from the values of other attributes, and therefore they do not have to be stored explicitly. Now, an example is age can be calculated from the date of birth, assuming that the birth date is an attribute that is available for the entity. The next concept is strong and weak entity, where an entity type that does not have a set of attributes that can help in uniquely identifying each tuple is known as a weak entity. In other words, you can say that a weak entity does not have a key. Now, the ones that do have a key are referred to as strong entities. Next, we're going to talk about participation, which can be total or partial. And given that an entity of a weak entity type cannot be uniquely identified because of the lack of a key, it has a total participation constraint. In other words, it has dependency on another entity, and that is known as the identifying relationship that exists between the two. Please note that it should not be considered that any entity type on which a total participation constraint exists has to be weak. For example, if we have a department entity and a manager's entity, which looks into a manager taking care of every department, or a manager for each department, then the department has a total participation constraint with manager's entity. However, it is not weak. Here is an ER notation diagram, which talks about how you represent all the entities, attributes, relationships in an ER diagram, and this can help you identify whether an entity is strong, which would be shown with a solid rectangle, versus a weak entity, which would be shown with double rectangles here. And the idea is you can look into what kind of a relationship it is, what is the kind of participation, is it total participation, is it partial participation, and the relationship has a separate notation, of course, which can help you identify what kind of a relationship it is. For the rest of this session, we would be considering primary keys with the notation as you see here, and the foreign keys with the notation as you see here. Now, here's the first step for converting an ER diagram to relational model by starting with identifying the regular entities. And for every strong entity, you are going to create a relation. Let's call it as R. And you would include all the simple attributes and identify the primary key for that relation. Now, if the key that you've chosen is composite in nature, then the primary key would be the combination of the simple attributes. And if there are any foreign keys or any relationship attributes that are not considered in this step, we are going to get to it in the subsequent steps. But for now, it's mainly identifying the entities and collecting the simple attributes and choosing a key. In the second step, we would identify the weak entities, and for every weak entity, creating a relation is next in line. Now you would again include all the simple attributes, include the foreign key of that relation to be the primary key of the associated owner entity. Now keep in mind, given it's a weak entity, it would not have a primary key of its own, hence the foreign key. So for this new relation R that you're creating, the primary key that you would set is the combination of the primary key of the owner entity and the partial key of the weak entity, if there is a partial key. Now, the third step involves including all the relationships of the type 1:1. So let us consider two relations, S and T, and we are going to take them from two entities, E1 and E2. So E1 corresponds to relation S and E2 corresponds to relation T. Now, there are three possible approaches. The first approach is you can have a foreign key approach, which involves two relations. In the second approach, you can have a merged relation approach, which would only have one relation. And then you have the third approach, which is the cross-reference or the relationship relation approach, which includes three relations. The next step involves mapping of binary relations between the entities. The first approach is the one that includes two relations. And if either of the two have total participation, then that is what would be considered as the base relation. So you need a base relation irrespective of what kind of participation. Now here with approach one, you're deciding to have that particular relation which has total participation to become the base relation. And you would include the primary key of the other entity to be the foreign key of this base relation. And if none of them have total participation, meaning neither S nor T has total participation, then you can choose either of them as a base relation. It doesn't matter. The second approach is the one that involves having just one single relation, and that's when you have total participation by both S and T, or E1 and E2. And you would merge the two relations and have a single relation. And the primary key of this new relation would be the primary key of S combined with the primary key of T. And in step 3, you also include any simple attributes or the simple components of any composite attributes. The third approach involves creating a third relation. So this is in addition to S and T, where you're going to cross-reference the primary keys of both the tables. And this approach is particularly used for M:n kinds of relationships. And you would include the primary keys of both the relations into the third relation as foreign keys to S and T. Now, the primary key of this relation R is going to be one of the two foreign keys, and the other foreign key, of course, that can still be used to uniquely identify the relation R. And you call this kind of approach as relationship relation approach. Now, again, you would include any simple attributes or the simple components of the composite attributes. With that, we will go to step number 4, which looks into mapping of binary relationships of the type 1:n. Now, keep in mind here the order matters. So here the sign denotes a relationship between the two relations S and T. This is 1:n. And the foreign key approach says for any regular binary 1:n kind of a relationship referred to as R, you would identify the relation that is on the nth side of the relationship, which is T in this example, and you would include as the foreign key of this relation to be the primary key. And you would also include any simple attributes of the type 1:n. The second approach that you can use for step number 4 is the relationship relation approach that we've discussed before. However, it should only be used if there are excessive null values in the foreign key. Step number 5 looks into M:n relationship types between the S and the T entities. And we start by creating a new relation referred to as U to represent the relationship relation here. And you would include the foreign key attributes in this new relation that would be the primary key of the two entities S and T. Now, if there are any simple attributes of the M:n type of relationship, then you would consider them to be attributes of the new relation. In the next step, we look into the multi-valued attributes, and any attribute which is of the type multi-valued would be represented or denoted with the notation A. Here we would create a new relation specifically for every multi-valued attribute, and the relation would have an attribute for the attribute A as well as the primary key for the relation which had the attribute A to be the foreign key of this new relation. And the primary key of this new relation is going to be the attribute A along with the primary key of the table or the relation which has the A attribute. Now, if A is composite in nature, then you would include all the simple components. In step number 7, we look into mapping any of the ternary relationships, and you would consider creating a new relation to represent every relationship which has more than two entities. Now, you would also have the foreign key of this new relation to be the combination of all the primary keys. For example, if it was a ternary relationship between entities S, T, and U, then the primary key of the three entities would become the foreign key of the new table. And you would include any simple attributes. And finally, the primary key of this new relation would be the combination of all the foreign keys. Now, here is an example, which is an ER diagram for an employee with multiple entities such as department, project, dependent. And here is the schema diagram, which shows all the foreign keys. Now, once you do the mapping from an ER diagram to a relational model, here's a summary of the 7 steps that we just discussed. And in the subsequent slides, you will see the example worked out step by step for the example with the employee entity. Thank you.